1993, number 36. So we have a definite integral here. And you want to approximate the net area, basically, of two inscribed rectangles of equal width. So if you're going from 0 to 2, the width of each one is going to be 1, because there are two of them with equal width. And we're doing trapezoidal rule. Okay. Oh, trapezoid. Whoa, 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 whoa. Oh, you're comparing it to trapezoidal. I'm sorry. So first you're going to do rectangles, Riemann sums using rectangles, and they're inscribed, and you're comparing it to the approximation using trapezoidal. So we have two different things going on here. So what's inscribed? Inscribed means it's inside. So if you draw a rectangle from 0 to 1, and it's going to be inside of the graph. Uh-oh, I didn't want to do that. That's inside, inscribed. If you went all the way up top like that, that would no longer be inscribed. Okay? So you're going to draw a rectangle here. And so the area, or the integral, I should say. Let me erase that. No, don't do that. The integral using the inscribed is going to be approximately, and here's what's kind of weird. Inscribed, usually, like, you have a shape. Let me give you a little example. If you have a circle, if you inscribe a triangle, the triangle's inscribed, it's going to be inside. Okay? But you would say the circle circumscribes that. So here's the good news for you. They don't use that terminology anymore, so you don't have to worry about that. So what's weird is you have two perspectives. Are you talking about inside of this or inscribed underneath that? So it's kind of, to me, kind of vague, but we'll go with the first one, inscribed meaning underneath it. And the height of that rectangle is 1, and the width of that rectangle is 1. Now we need the next rectangle, and that's going to be drawn here. And so what's the height of this? The distance from there to there. Well, it's the function at 1. If you plug 1 here, that's going to be e. So the height of this is going to be e. So the height is e, and the width's going to be 1. So that's going to be doing the rectangles. Now let's try doing trapezoid. Oh, I hate when it does that. Now we're going to try trapezoidal. So instead of drawing rectangles, we're going to draw trapezoids. So the first one that I'll do will be here. What's the area of a trapezoid? It's 1/2 the sum of the bases, and the width's 1. So I need to figure out this height and this height. Well, I know this distance is 1, because if you put in 0 here, this comes out to be 1. So I know that the vertex of that thing is at 1. What's the height here? Well, you got to plug 1 into your function. If you plug 1 here, you get e to the first. So this side is going to be e. So the sum of the bases is 1 plus e. Now the second one I'm going to do is going to be here, that trapezoid. Same formula, 1/2, the sum of the bases, the width is still 1. The left side is e, but the question is, how big is that? Well, I have to plug 2 into my equation. That's e to the 4th. So the length of this side is e to the 4th. That's my other base. So you pop this in your calculator. That's the trapezoidal. That's the rectangular. And you'd have to subtract that to get your answer.